Okay, so today we're going to talk about current. When I think of current, I think of the flow of a river. And I want you to visualize this when you think of the physics definition of current. In physics, current is just the flow of electrons. So it's the amount of charge passing through a section of wire per time interval. Per second. Great. So, and again, I think of it as just the flow of electrons. So go ahead and encourage you, go ahead and guess the formula for current, and then you can check back in on the video. Okay, so when we think of current, it is the symbol we use for current is I. So current I is going to go ahead and be current, and it is measured in amps oftentimes. Or we can say amperes. So current, it's the amount of charge, and the symbol we use for charge is Q. So it's going to be amount of charge, how much charge changes or goes through. Okay. So it's the amount of charge per time interval. And we'll oftentimes measure delta Q will be in coulombs, and delta T will oftentimes be in seconds. So Q is the charge passing through surface, and the delta T is the time interval. So we know current can be measured in amperes. Let's look at it. What else can it be measured in? Well, current is charge per time, so it can also be measured in coulombs per second, or C per S. Okay, so when we talk about current, we'll often talk about the actual current, what's actually flowing, and the conventional current. So let's say I have a wire. And for this wire, I'm going to go ahead and say, let's say I hooked it up to a battery, and we have a positive side of the wire, so the positive terminal, and we have a negative side of the wire, the negative terminal. And what flows? Is it the electrons or protons that flow? Well, we know those protons are tight in the nucleus. Those do not want to move. It's going to be the electrons that are easier to move around. So electrons are going to want to flow. And do the electrons flow from the negative side to the positive or the positive to the negative? Electrons are repelled by negative and attracted to positive. So this is going to be the direction of the actual current. So flow of electrons from negative terminal to positive terminal. So when current was actually discovered, and it was discovered by Benjamin Franklin, did a lot of research on it, is he thought it was the positive charges that move. And this is what we call the conventional current. So again, if we have our terminals, so hook this wire up to a battery, and we have the positive terminal, and we have the negative terminal. He assumed it was the positive charges that move. So are those positive charges going to move towards the positive or towards the negative? Opposites attract, so they're going to move towards the negative. So this is the flow of positive charges. So again, this is not what actually happens, but this is what we say it is by convention. We're now going to go ahead and solve a problem involving current. So we have this problem, 3 amperes of current flow through a wire. For A, we want to find what net charge flows through a point in the wire in a minute. Okay, so let's go ahead and write down our given. So we have I, delta Q, and delta T are our givens. And again, our current equation is I equals delta Q over delta T. Great. So 3 amperes. I know amperes is the units of current, or you could say coulombs per second, so I'll put 3A right there. For A, we want to find the charge. That's going to be delta Q. And delta T is 1 minute. Great. So we said we need to, let's always be careful with units. So we need, charge will be in coulombs. Okay, so we know that's how it'll spit it out. 1 minute we need to convert to seconds. So I know 1 minute is 60 seconds. Great. Now we can just plug everything into this good old equation. So amperes is 3, delta Q we want to find, and the time is 60 seconds. So I get to do some good old multiplying, and I get 180 coulombs is the charge. And that is our answer to A. Cool. Let's go ahead and look at B. So how many electrons flow through a point in the wire in a minute? Okay, so we know there's 180 coulombs of charge. And I know that one electron, I'm going to write this up here, is equal to 1.6 10 to the negative 19 coulombs. So the charge on one electron is, and I should say, negative 1.6 10 to the negative 19 coulomb. So if I have 180 coulombs, and again, that's 180 coulombs of like negative charge flowing through, I'm going to convert that to electrons. So if I want coulombs to cancel out, it has to be on the bottom. Electrons will be on the top. So this will be 1.6, if I don't give myself quite enough writing room, times 10 to the negative 19 coulombs per one electron. Cool. So coulombs will cancel out, and we're just left with electrons. One little hint, when you're plugging this in the calculator, make sure you have this whole bottom thing in parentheses. So I got 1.125 times 10 to the 21st electrons. So quite a few electrons are flowing through. Cool. So now let's go ahead and look at point C. So the net charge on a wire. Okay, so do we want wires to have a charge, or do we want them to be neutral? We want wires, like the wires in our house that powers like all our lamps and etc., fridges, TVs, laundry. We want the charge to be neutral. And if I think about it, if for every like one electron you put in, one electron is going out. Just because it's like the flow of a current, it's flowing, continuously flowing. So the net charge is just going to be 0. There's the same number of electrons pumping into the wire as that are being pumped out of the wire.